Alright, so let's have the application of integration 3, and it is undeniable that this is one of the most essential things that you have to understand in integration when it comes to its application in higher engineering. So we have application in ChE, thermodynamics and physical chemistry for the first one. And we'll just be dealing with the first law of thermodynamics here, which states that although energy assumes many forms, the total quantity of energy is constant, and when energy disappears in one form, it appears simultaneously in other forms. So we'll be utilizing the general concept of the internal energy, which is this one, du is equal to dq plus dw, which only means that any change in the internal energy is equal to the changes, the sum of the changes of the heat and of course work. So it could be that this heat could be that it's exothermic, endothermic, or if it's work, it could be expansion or compression, so positive or negative work. So this equation du is equal to dq plus dw is a general expression of the internal energy. It could also you can also use minus dq minus dw, so it just depends on the sign convention that you'll be using, but in general we'll be using the sum of q and w. So you already know this expression. If you have an integral of any variable from p1 to p2 or point 1 to point 2, that's just the difference between these two points in the general sense that it is a continuous function. And remember, if you want to think of this as an infinitesimal change, we could relate this difference as the delta difference of that certain variable. So in this case, if it's pressure, then if there is an infinitesimal change between P2 and P1, so that difference becomes delta P. Of course, that a certain concept is only applicable when there's an infinitesimal change now. But then we usually use that concept in expressing the change in any two points. Kasi delta means change. So if you have 2 points, then the difference between these 2 points would always be the change. So this is very common in reversible processes, and this is the expression for the work in a reversible process. So the work, or the dW, that's the differential work, that is equal to negative p dv. So you have to remember this formula, and then you can integrate both sides, and then you'll be getting this negative p, the integral from v1 to v2 dv. So that's just the general formula for our work, and we'll be considering work in this case. The work in thermodynamics and physical chemistry is simply given by negative p, the integral of dv from v1 to v2. And before we solve for that, let's discuss first the second part of this application in higher engineering, which is about the reaction kinetics. Now, reaction kinetics is one of the subjects that will give you a review of your integral calculus, because it will really use a lot of integration processes. But of course, there are equations na already given na, final formula na yung integrated. But when it comes to the plug flow reactors, that's one of the many reactors that we have. We have constant steered tank reactor, yung mga CSTR natin. We also have yung mga batch. But when it comes to the plug flow reactors, and of course yung batch natin, we have to always integrate this. So from this, let's have a quick discussion muna kung ano ba yung mga PFR natin, or tubular reactors. So PFRs are models for continuous flowing systems in cylindrical geometry intended to avoid longitudinal mixing. So for example, meron tayong mga components, so we have to mix. And then when it comes to a point wherein pinapump mo siya, and then nagmi-mix tuloy siya along or across the flow. So in that case, the mixing is no longer efficient kasi nga you're mixing along the flow, the region of flow. So in that case, because it is no longer parang efficient, you have to make sure na you avoid that, and plug flow reactors are used to avoid those certain scenarios. And we do have a lot of cases here. The first one is the constant volume, wherein there is no expansion of, let's say, gases or fluid. So for an ideal system with a constant volume, the concentration of the species is Ca. So this is the concentration in moles per liter, or molar, so at any residence time. So the residence time is expressed in the Greek letter tau, which is generally the amount of time required for the reaction to proceed. Remember, you have this parang discussion ng kinetics sa inyong chemistry. And before that, you were having this mga first order, second order. And that's the same thing here. Para yung difference lang siguro is that we're leveling this up and we're putting this inside a certain reactor or a vessel wherein they can freely like react and then make may parang contribution yung size ng vessel dun sa kanilang certain reaction. So that's the quite the difference. And then n is the order of the reaction, so it could be 1, 2, 3. So pwede rin yung ganun. Sometimes the order of a reaction is also like 2.5, 1.1. So may mga cases din na ganun. And then of course CAO or C sub AO is the initial amount. So for example, nag-start tayo sa 4 moles inside a 50-liter vessel. So that's just the quotient of that kasi you have to express that in terms of molar or moles per liter. And then the conversion, that's X sub A. So whenever you have, let's say, a reaction that is converted to, let's say, 50%, so X sub A mo is 0.5. So yun lang naman yung concept ng ating PFR. And then K na this is the letter kappa in Greek. So yung K na yon is the rate constant with unit depending on the order of reaction. So para lang din tong K natin dun sa kinetics natin, chemical kinetics, it's just that this K is related to the dimension of the vessel. So yun lang yung pinakaiba, kaya iba na lang yung symbol. But then again, that's the same concept. And this is the general formula for any constant volume PFR. That's CAO, which is a constant here kasi yan naman is initial amount, so constant yan. And then integrated from 0 to XA, the XA divided by CA sub ON, and then 1 minus XA raised to N. So technically, our variable here is the conversion. Parang conversion percentage, ganun. Or current conversion fraction. And then we have the variable volume, which in this case, the expansion is not equal to 0. So sometimes, when we try to react a certain material, let's say gases, especially mga gases. So hindi sila nag-i-stay dun sa point wherein same volume lang sila. They tend to expand. So in this case, we are counting the expansion of gases in that case, and then it's no longer the same equation because the volume has already changed. So in this case, yung ating reactor, medyo lalagyan natin ng konting space, and then we will try to like provide that allowable space, and then yun natin is consider din natin yung allowable space na yun. So the formula for this is the same as the previous one. It's just that meron lang tayong incorporation ng 1 plus EAXA raised to N. So yun lang yung nadagdag. So you just have to remember this additional factor, and then that's just the same equation. Now for batch reactors, so ang pinakaiba naman ito, di ba yung PFR natin is used to avoid longitudinal flow. It's like a tubular cylinder na pahaba. So ang batch reactor naman, usually ito yung mga parang, kung nakakita na kayo ng, kapunta sa mga company, ito yung usual natin na nakakita ng mga vessels na, parang naka-erect lang siya na cylinder, ganon. And then, these batch reactors are actually one of the oldest and simplest type of reactors wherein kapag naglagay kayo din ng components, i-allow nyo lang siyang mag-react. Let's say, meron kayong fermentation process, so i-allow nyo lang siyang mag-react doon. And then after some time, which is tau, yun, you will be removing all those components. So yun lang naman yung concept ng batch. Kaya nga tinawag siyang batch, ibig sabihin first batch, second batch, after some time. Ganun. Okay, so for the formula for the constant volume, that's just the same as the PFR. So wala kayong kailangan sa ulit bagong formula kasi this is just the same. But for the variable volume, magkakaroon din kayo ng 1 plus CAXA factor, but remember, the difference is just that wala itong raised to N, pero yung PFR natin meron siya. So yun lang yun, pinakaiba ng batch reactor in variable volume. So technically, the constant volume in batch and then the constant volume in PFR has the same or have the same equation. But for the variable volume, pinakaiba lang niya is raised to wala siyang raised to N kasi yung N is technically 1. So parang pwede naman kayo maglagay ng N, but remember, N is equal to 1 kaya mawawala lang din siya. So that's it for our chemical reactors. So let's have the problem solving later, and let me just discuss muna yung unit operation na filtration dito. Kasi filtration is one of the most difficult topics when you don't understand the concept of integration. Kaya I want you to understand this, like, hindi naman sa sobrang talaga yung sobrang hardcore UOps, no? Para at least lang yung concept ng integration niya is magets niya, no? So, just to tell you a quick review about this filtration. So, it's one of the unit operations. Sabihin natin na yung unit operations natin is your major, diba? And yan, a unit operation is like a certain process wherein meron nagaganap doon na conversion of the raw materials into a specific product. So, yun usually yun. And there are a lot of unit operations that you can think of. Meron tayo dyang mga evaporation, crystallization, screening, napakarami, no? And then, this unit operation filtration is one of them. And you'll be discussing this, I think, on 4th year or 3rd year, probably. So, even though sa 3rd year pa siya di-discuss, hindi ko makipapahirapan ng ganun dito sa problem na nag-involve ng unit operation. Actually, ito lang ay direct substitution. Pero you have to understand muna yung mga concept ng ating filtration. So, filtration, isipin nyo lang meron kayong certain filter. So, ito yung filter mo. Okay? So, ito yung nagsasala nung ating water or water solution, diba? So, lagyan natin ng mga label to. So, meron tayong filter and then, ano ba yun nandito? So, it could be pressure filter or gravity filter. So, yun lang yung two types natin. Pag sinabi nating pressure filter, usually oriented yan horizontally, no? Then, meron dito mga filter. So, gagawin yan, ipupush yan yung amount of parang fluid na nandito siya na pumapasok dito. So, once it is being pushed, so kaya nga pressure. So, ibig sabihin nun, tatapos natin filtration through pressure. But when we say gravity filter, for example, ito yon, hahayaan lang natin na nandun yung ating fluid and then meron dito mga layers of filter na hintayin lang natin na mag-subside siya and then until, yun, dadaan lang siya dun sa filter na yun and then makukuha na natin yung ating tinatawag natin na filtrate. So, yun yung gravity filter. At ang pressure filter, yung pinagkaiba nila. And then, the liquid known as the filtrate is removed from the mixture. So, that means na whenever you have a liquid na pumasok sa filter, yung lalabas dyan na fluid, we call that the filtrate. So, yun yung first term na you have to remember. Meron kayong certain initial na solution na kailangang i-filter, lalabas doon na filter natin, we call that the filtrate. Yung lumabas na tubig. And then, next one is, and then yung filtrate natin, yun yung ating V. Okay, so, we will be solving for the amount of filtrate that is being produced in this process, not the amount na finifilter natin, ganun. So, accumulated solids are referred to as the filter cake or simply cake. So, di ba, meron kayong solution dito and then meron kayong filtrate. Di ba, may mga parts dito na maiiwan at then meron din sa mga part dito sa filter. So, we call this the filter cake or simply cake. So, yun, hindi lang sa birthday may cake, meron ding cake dito sa filtration. So, any amount na magsa-sediment dun sa parang filter natin would be called the filter cake. So, the time of filtration, theta, so is the time elapsed when the necessary filtrate is obtained. So, for example, it took me, let's say, 4 hours para makuha itong filtrate na to. So, that is your theta, that's 4 hours. So, yun lang naman yung usual natin na terms. And then, meron pa tayong kailangan i-consider dito. When it comes to pressure filters, meron tayong tinatawag na differential pressure. So, halimbawa, since kailangan ko ngang i-push yung fluid na yun kasi medyo mabagal yung ating filtration process, so, meron tayong tinatawag na differential pressure which is the pressure required to something like drive the process. So, yun yung delta P natin. And then, yung cake resistance natin. So, alam naman natin na 'di ba meron tayong nabubuo dito ng mga sediments. So, 'di ba, if you could think of this, so hindi naman natin tinatanggal 'to. So, as we proceed with the process of filtration, madadagdag 'to na madadagdag. And actually, filtration is something like nagbi-build up yung ating resistance dun sa ating cake. Kasi remember, since this is a building up, nagkakaroon to ng parang additional layer of filter. And we call that the resistance that is offered by this cake, the specific cake resistance alpha. And of course, meron siyang density, then we call that the density of the filter cake C. So, yun yung other parameters na pwede natin incorporate dun sa ating cake. And now, we also have the viscosity, which of course, alam niyo naman ang viscosity. That's mu. So, intensive properties to lahat ng ating mga filtration. So, that means na ito lahat will be given and they're all constant. So, wala kayong dapat problemahin dyan. So another very important factor is the fictitious volume, which is the volume deposited upon saturation of the filter cake at the filter medium. So ito pa yung isang parang other term na you have to remember, the fictitious volume. So pag sinabi natin fictitious volume, di ba kumukuha tayo dito ng filtrate? Yun yung lumalabas. But remember, kung pipigain mo yung filter cake na yun, meron ditong amount na natitira na parang certain volume pa na hindi na makalabas kasi nga na-trap na sila dun sa mga parang iskinito dito sa ating filter cake. Which hopefully na-encounter nyo na siya. Hopefully nakapag-filter kayo nung high school, di ba? Ano ba, meron kayong filter paper, doon na lang sa filter paper, di ba? Tapos kayo mag-filter, may tubig. Di ba itong filter paper, basa-basa pa yan. So pag piniga mo yon, yung lalabas na tubig na doon or whatever fluid is that, we call that the fictitious volume. Kasi yung volume na deposit upon saturation of the filter cake. The next concept or the next thing that we have to understand here is the formula. So the formula for finding the rate of filtration is this given by the Ruth equation. So ito yun. And then that's the RF is equal to the filtrate, the amount of filtrate being collected per unit time. That is equal to the negative differential pressure area squared divided by alpha C mu V plus V. So hopefully nakita nyo na lahat ng mga variables na to dun sa previous discussion. No? So ito naman lahat is, di ba sabi natin, these are constants. So constant tong area, constant ang alpha, C, mu. So, we can take all of this as your K. Meaning, nilamp up natin sila lahat as a constant. Yan. And then, this is summarized in this expression, negative K delta P V plus V, wherein this is the amount of filtrate that is being collected, and then this V sub E is the fictitious volume. So, yun lang. And then, if you have a constant rate of filtration, so this becomes modified. Instead of having dV over theta, since we have a constant rate, mawawala na yung change nila. So that means parang pwedeng tanggal, di ba, from dV over d theta, from this one, tanggalin mo lang tong d. Kaya maging v over theta na siya, and then, di ba sabi natin dito that that's delta p. So you will transform this in terms of integral, so that becomes p1 to p2 dp. Kagaya nung kanina natin yung parang expression ng differential natin na pressure. So, ito na yung magiging equation natin for constant rate filtration. But when it comes to constant pressure, so, ang nangyari, itong pressure na to, it becomes constant. So, hindi magsi-zero, magiging matatanggal lang yung ating delta dyan. Pwede mong sabihin na that's dp. So, matatanggal lang yung d dyan, and then magiging p na lang siya. But then again, itong v over theta, babalik siya sa dv over d theta. So, yun. Okay? And that's it for the two cases na meron tayong constant rate and then constant pressure. So, in the higher engineering process kasi, sometimes this is a combination of the constant rate and constant pressure. So, after mong maggawa ng constant pressure, magko-concentrate ka naman. So, may mga ganong cases, but of course, I will not be dealing with those dito kasi ano lang naman to, parang application of integration. And then, to solve for yung mga volume natin, since this is actually a differential equation already. So, kung mapansin nyo kasi, diba, dalawa yung ating differentials dito. So, we have to make sure na we separate this, na separation of variables yung gagawin natin. So, we could multiply this whole term by V plus VE. And then, yun. So, from this, ang mangyayari dyan, maging V plus VE dV. So, ito pala times, d theta. So, parang ganyan yung multiplier natin both sides. So, yan. So, from this, magiging V plus VE na lang siya, dV. Wait. So, V plus VE dV, which is equal to negative KP d theta. So, yun yung magiging expression natin. And then, of course, to determine yung V natin, we have to integrate both sides. Kaya, ito yung magiging final expression natin. When we want to solve for the value of V and then theta. Bakit kasi in-integrate natin ito, yung isa hindi? Kasi kung mapapansin nyo, this one has already the V and theta. Pero since this one is not yet integrated, then we have to incorporate yung integration on both sides. Kaya dun palalabas yung ating expression of the integration. Unlike this one na meron na tayong integration part, dun pa lang sa ating P. So yun yung difference nung dalawang yun, constant pressure and constant rate. Actually, ang kailangan nyo lang ko dito, solve nyo lang yung formula and that's all. And then finally, we have the application of statistics. So this is the area under the normal distribution curve. And I know already that you have already encountered this one in your high school. But then again, I remember that students always use something like a t-table or a statistics table for this. So actually, you can determine the area under a normal distribution curve without using any table. And this is the formula for that. If you have the probability density function under this curve, that is equal to 1 over the sigma square root of 2 pi. And sigma here is the standard deviation. Okay, that is integrated from x1 to x2 and then negative 1 over e raised to 2 sigma squared x minus mu squared, wherein mu natin is yung mean. So, this is kind of long, pero ito yung general expression. But when it comes to the standardized normal distribution curve, so mangyayari dyan yung ating mu or mean, magiging 0 siya. Mean, that means average siya. So yung mean natin, it becomes 0, and then yung ating standard deviation, it becomes 1. So the previous expression here simplifies to this 1. 1 over square root of 2 pi from z1 to z2, and then e raised to negative 1 half z squared. So if you're asked, what is the probability or what is the value under this, let's say z2 and z1, so you just have to use this formula, and then you'll be able to determine that without using any statistics table. So with all this being said, let's try to solve muna yung ating mga problems. So the first one is find the reversible work done during the isothermal expansion of 38.27 grams of oxygen gas from V1 is equal to 0.3 cubic meter, that's the first volume, to the point V2, which is equal to 1.72 cubic meter, that's the second volume, V2, at a temperature of 25 degrees. Kulang to, 25 degrees Celsius to. Kasi hindi may Kelvin, wala naman tayong degree sa Kelvin. So anyway, so let's proceed with the computation. Sabi natin, ang reversible work natin is given by negative P, the integral of from V1 to V2 dV. So that's our reversible work. And then sabi natin dito, we need to determine the work in the isothermal expansion of 38.1. So that means na constant yung ating temperature kasi isothermal. And then, ano ba yung pressure natin? Supposing that this is isothermal process, we can think of this as the oxygen gas being an ideal gas. So from this, knowing that this is an ideal gas, we could just use the ideal gas law, that's PV is equal to nRT. And what is the expression of the pressure? Because I want to express this pressure in terms of temperature and then the volume. So that's P is equal to nRT over V. Therefore, the new equation that I'll have would be W is equal to negative nRT, the integral of V1 to V2 dV over V. So, bakit ko pinasok yung V doon? Kasi this V is the same variable as this volume. So, kailangan ko siyang ipasok doon. Kasi pag nilabas ko yan, hindi natin siya ma-integrate, diba? So, yung nRT lang natin yung ma-fix dyan. So, therefore, our work is given by negative n. So, ano ba yung number of moles natin? So, 38.27 grams. So, syempre, grams yan. So, we have to convert this in terms of mole kasi nga, that's n. So, ano ba yung ating molecular weight ng oxygen gas? So, that is 32. Diba? 32 grams per mole. So, bakit 32 siya? Kasi 16 times 2 is 32, diba? This is a diatomic gas. So, 32. And then, ano ba yung ating R? So, we'll be using, since we have here yung cubic meter, and then moles, and then kakelvin natin to. So, we have to use yung ating R, which is the 8.3145 joule per mole Kelvin. Okay? Since we're dealing with work, so it is a lot easier for us to use this R. And then, the temperature is 25, so you convert this in terms of Kelvin. So, that's 25 plus 273.15 Kelvin. Okay, so we do have the Kelvin na, mole na rin to. And then, what is the integral from V1 to V2? That's 0.3 to 1.72. And then, you just have to write dV over V. Okay, and that's it. So, the work gives you negative 5177.2313 joules. So, that's it for this first problem. So, you can cancel out moles, gram, Kelvin. So, you'll be left out with joules. And then, ito naman is dV over V. So, yun, wala naman siyang magiging unit. So, yun lang yun. Then, the work is just this negative 5177.2313. And that's it for the work. for this first problem. So how about the second one? It says here that the work done during the adiabatic compression. So ito naman iba naman process. Ito na isothermal expansion, that is a constant temperature. Ito naman is adiabatic compression. So yung ating heat dito is 0. So the adiabatic compression of a carbon dioxide gas from 20 cubic feet. So parang ito yung ating V1 and this is your V2. So remember, if alam naman natin na pag nag-integrate tayo, usually dapat mas mababa yung V1 sa V2. So, pwede naman ganun pa rin, mag-stick pa rin tayo na V1 yung ating mas mababa, but we have to remember na we have to incorporate yung ating changes ng sign. Okay, so that should be a reminder for everyone. And then, provided that the gas follows the expression PV raised to gamma is equal to 38. So, this is the equation that we'll be using na para ma-relate natin yung P in terms of V. Kasi this is an adiabatic compression. That's why meron tayong tinatawag natin na adiabatic constant. And that gamma is equal to 1.4. So, yun. And then yung P natin is in terms of PSI and then yung V natin is in cubic feet. So, determine yung ating work. Pero remember, yung work natin is in foot-pound-force. So, we have to convert this PSI in terms of pound force per feet squared. Ito kasing ibig sabihin ng PSI is pound force per inch squared. Yan. So, we have to convert this in terms of pound force per feet squared. Okay, so with this, let's try solving for the work. So, the work is always negative P, the integral of V1 to V2 dV. But this P now is 38 over V raised to gamma, and gamma is 1.4. So, with this, the work becomes we have 38. The integral from V1 is 20, 8, and then we have dV over V raised to 1.4. So this is your expression. And then you should be getting a value of around 12. That's positive 12 point, sorry, I forgot the negative here. So that's positive 12.688 8. So remember, kung ayaw nyo gamitin yung lower limit na mas mataas kasi nga nasanay na kayo sa mas mababa lagi siya. So you have to make sure na you make this positive. Parang magre-reverse kayo ng sign. So that's 12.688. So the unit here is actually in terms of pound force per... So since diba this one is in terms of PSI, so that's in inch squared. And then of course, times cubic feet. So ganyan yung unit niyan. So we have to convert this in terms of pound force feet. So we have to make this in terms of feet. So diba, i-multiply natin to ngayon sa 12 inches per 1 foot raised to 2. Kasi diba dapat feet squared. So 144 dapat yon. So with this, we can cancel this out. Okay? And then, matatal na sa atin is foot pound force feet. So W will give us a value of na positive 1827.1892 foot pound force. Okay? So that is the final answer. So dito, pinaka-importante lang is matandaan nyo na since we're in PSI and the unit is foot pound force, so you have to convert this PSI in terms of foot pound force per feet squared. So yun, pero if ever naman na yun lang yung sagot nyo, 12.6888, and then yung unit nyo naman is yung previous kanina, so pala din problema, tama rin naman yun. But basta, dapat yung unit is consistent kasi kung ang nilagay nyo yung sagot is this one, and then yung unit nyo naman is itong foot pound force, so mali rin siya. Okay, so hopefully ay na-encounter nyo na itong mga gantong units sa physics. Okay, and then let's have number 3. So sabi sa number 3, if the heat required to raise 5.17 moles of combusted diesel, and we're assuming that the constant pressure from a temperature of 300 Kelvin to a certain temperature T2, yun nga, is 25.60 kilojoule, find the final temperature. So this is the formula you're already given, and then yung specific heat capacity is 5R over 2. So we need to determine T2. So ito lang naman is just a mere substitution. Yung Q mo is 25.6 kilojoule, so that's 25.60 times 10 cube joule. Okay? And then ano ba yung N natin? So N is 5.17. So yun lang yan. And then ano ba yung ating CP? Sabi dito, CP is 5R over 2. So that means I have to multiply this by, Your R is 8.3145 and then you multiply this by 5 halves. Okay? And then, ano ba yung ating T1 to T2? D2. So, dito natin kukunin ngayon yung T2. So, what is the integral of dt at T1 to T2 dt? So, that's just the difference between T2 minus T1. And your T1 is simply equal to 300 Kelvin. So, ito na yung T2 minus T1, which is simply the integral from T1 to T2 dt. So, ito yan. So, that is our expression. Therefore, upon shift solving, T2 would be equal to 538.2173 Kelvin. So, whenever there is a new parang concept na ibibigay dun sa problem, you'll be given naman ng mga equations like this one para hindi na kayo maghanap pa. Kasi you're just starting to understand naman yung thermodynamics. But kasi nga, we have to understand this kasi sobrang mahirap talaga siya pag hindi na-discuss prior to thermodynamics or physical chemistry, yung mga integration procedures na yan.